minus 3 times m minus 4.
Good. That's it, right?
Yeah.
That's for the fifth derivative, right?
Mm-hmm.
Now, if you are not sure, just find all the derivatives and plug them in like how we did it up here. Okay, you go through all of these steps right here to get your auxiliary equation. Okay, if that is how you want to do it. Okay, I don't want to do that. Okay, because after that example, I know the pattern already. Now let's go to the second term, which is plus b. Plus b what?
Times m minus 1 times m minus 2 times m minus 3.
Good. And then the third term, for the third derivative, you have c what?
m times m minus 1 times m minus 2.
M times m minus 1 times m minus 2, right? So we run out of room. So we go down here, say plus. And how about the y double prime, which is d
m times m minus 1.
and then the y prime should be e m. And then what? For this term, what would you get from that?
Just
F.
Just f. And then equals 0. So that is the auxiliary equation. Okay? For this fifth order Cauchy-Euler differential equations. All right. So let's look at the case for the second order. Okay, so here is the auxiliary equation of the homogeneous. Oh, I'm supposed to have it. Okay, at 123% zoom. So everything is going to be inside the window, the screen when I switch back to my my Surface Book. Okay, so here is the auxiliary equation for the second order homogeneous Cauchy-Euler differential equation. Okay, and you know that this is a quadratic equation. So similar to what we did in section 4.3. So this is a quadratic equation. So it has two roots, right, for m. If you multiply everything out and solve for m has two roots. So there are three cases, just like how we did in section 4.3. M is equal to two distinct roots. Now, if m is equal to two distinct roots, say m is equal to m1 and m is equal to m2, then the two solutions of this homogeneous equation are, the first one is x, because remember, the solution has to form x to the m. So x to the m sub 1. And the second one is x to the m sub 2. Okay? Now, the second case is when the root repeats. Let's say it repeats. In this case, because it is a quadratic equation, so if it repeats, it can only repeat twice, right? So we say it has multiplicity 2. Okay, so let's recall. Remember, if it repeats 2 back in section 4.3, then y1 is equal to e to the x. What is the second one? For section 4.3, the normal differential equation.
X to the EX.
X, EX.
X e to the ax, right? If it repeats 3 times, then it would be what?
X squared e
Squared.
Very good. Okay, so that's what you learned in section 4.3. Okay. Now, in this case, so that's just a quick review, right? A quick review. Okay. Now, you know the first solution is going to be x to the m sub 1, because m sub 1 is the root, but it repeats twice. So you know that you're going to multiply something to it. So the question is, what are you multiplying? Okay. So it's going to be x to the m sub 1 times something. Okay, so this something right here is ln x. Okay, now if you want the y ln x, okay, if you want the y is ln x, well, you can figure out very easily. Okay, you can find this out. How are you going to find this out? This can be obtained by, okay, so this can be by the method of reduction of order. Okay, missing, supposed to go down one line, huh? By the method of reduction of order. Okay, so remember reduction of order. If I give you one solution, then the second second solution can be found by taking u, a function u times y1, right? So y2 is u times y1, and then you go through the process in section 4.2 to get u, and u turns out to be ln x. Okay, so I'm not going to go over that. All right, so we did that in 4.2. Now case number 3.
Sir,
Kate, yes.
So because we already went over that, are you saying that when we're doing this, we can just assume that
yes,
we can just use ln x just like normal?
Right.
Okay, wonderful.
Yeah, okay, it's just like this one right here. Back in section 4.3, we said if it repeated twice, then the second solution would be the first function times x, right? And then if you are curious why it is x, then you use reduction of order to find out what y2 is, right? So when you find y2 is u times y1, and that u turns out to be x. Now I said only if you are curious and you want to know what that is, how to get the x here, you can use reduction of order. So this is the method that will help you determine what to multiply when a root is repeated. Okay. So for Cauchy-Euler, if a root is repeated, you just multiply ln x. So let's say it repeated 3 times. Then your third solution is going to be x to the m sub 1 times what?
ln squared x?
You should say ln x quantity square, or you say the square of ln x, because when you say ln square x, that doesn't make sense, right? Okay, we don't have such notation. Okay, but I know what you meant. You got that?
Yes.
Okay, so similar to section 4.3, the number of times it repeats, you just multiply by that factor raised to a power 1 less than the number of it repeats. Okay, so that's what you have. Okay, so
Professor?
yes.
For case 1, what is YC supposed to equal?
Oh, YC, just like how we did it for section 1, 4.3, it's just a constant. Thank you for reminding me that. It's a constant times y1 plus another constant times y2. Okay.
Oh, okay. Thank you.
Okay, you're welcome. So here are the two solutions when m has distinct roots. Okay, and then the next one is this is when it has repeated roots. All right. Now the third one is when it has complex roots. Okay, so when it has complex roots, the roots are conjugates. Okay, so one is like alpha plus beta I, the other one has to be alpha minus beta I. Okay, but we don't want to have complex roots, right? We want to work with real numbers, so we want to have real roots. Okay, but before we can do that, then let's find out what the two solutions are when we get these two roots for m. So you know that the solution has to form x to the power m. So in this case, y1 would be x. Oops. X to the power m, which is alpha plus beta I. And the other one, the second one is x to the power alpha minus beta I. Yeah. But we want to have complex roots, real roots, right? So we need to rewrite this and take advantage of the Euler's formula that we used back in section 4.3. So here's how we rewrite. Rewrite the first one. We rewrite that as x to the alpha times x to the beta I. And then x to the beta I, we want to convert that into base e, right? So we can use Euler's formula. So this to the beta I, now you know x is the same as e to the ln x. And then so right here. So that is what we have for x, right? So that's x to the beta I. Okay, but when you have a power raised to a power, you just multiply. So that is the same as ln of x times beta I. And we write like this, okay? So with that said, this is like your theta over here, right? So that's e to the I theta, e to the I theta. So we can write it as cosine theta plus I sine theta. Okay, so this is going to be cosine of theta, which is beta ln x, plus I sine of theta, which is beta ln x. Please don't write ln x and then beta, okay? Because then it's harder to read when you write that way. Okay, so it's not good. Don't write like that. All right. So right here. So this is actually your beta, your theta. Okay. So what is x to the negative beta I? Well, x to the negative beta I, if you rewrite this one, then you're going to have a negative right here up here. So the theta is going to be negative beta ln x. Okay. So that is cosine of negative beta ln x plus I sine of negative beta ln x. But from trigonometry, you know that cosine of a negative angle is equal to cosine of the angle, because cosine is an even function. And sine is an odd function. So sine of a negative angle is negative sine of the angle. Okay. So that's what you have for x to the beta I and x to the negative beta I, right? So now let's get the solution. Y sub c is c sub 1, y sub 1 plus c sub 2, y sub 2. And what is c sub 1? What is y sub 1? So let's do this. So y sub 1 is x to the alpha beta I plus, and then c sub 2, x to the alpha minus beta I. So from here, you can factor out x to the alpha. And then in here, you have c sub 1, x to the beta I plus c sub 2, x to the negative beta I. And you know what they are. So x beta I and x to the negative beta I right here, right? So you just replace these two with those, okay? And try to combine like terms, just like how we did it. Okay, just like how we did it in section 4.3. So I'm not going to go over that again. That's just algebra. So after you do that, then you should get something like this. So you should have x to the alpha. Okay. And then on the inside, after you do some steps in between, you can combine all the terms containing cosine together and all the terms containing sine together. You're going to have something like this. I B. Okay. Okay. So what is that telling you? So let me rewrite these so you can see. Okay. So let me see. What should I insert? Should I insert? No. Let me just insert one. So let's do this. Let me see how should I write so you can see it better. Okay, let me do this. So let me just insert one step in between. It's not strange. It doesn't. Okay. Okay, I'm gonna move this one to the next step. Okay. If you use the pencil, if you're using a pencil, you can erase it easily, but you don't need to. Okay. So basically, right here, you just do x to the alpha, and then c sub 1, and then you can just write, okay, you know what? It shouldn't be a bracket. It should be a brace. Okay. So it should be a brace, and then c sub 1 times x to the beta I. X to the beta I is cosine of beta ln x plus I sine of beta ln x. So if you see this, you can understand better. Okay, and then plus c2. Okay, and then multiply by x to the negative beta I, which is cosine of beta ln x, minus I sine of beta ln x. All right. Okay. So with that said, I think let me make a note here. Move that a little bit to the left. Okay. So from here, so if you multiply okay, so this one right here. So if you multiply these two out, you're gonna have x to the alpha times that plus I, and then x to the alpha times that, right? But we want to have two real solutions. Okay, so we want to have two real solutions. So one of them is going to be x to the alpha. Okay, x to the alpha. What's going on? Is this moving? Yeah, next time I have to use, I need to use a glove so my palm doesn't move the screen. So x to the alpha cosine to the beta ln x. And then the second real solution is x to the alpha sine of beta ln x. Okay. Okay, I might even. Okay. So what is the general solution for if we want to work with real solutions? So the general solution is going to, so here's what you have. You have for complex root, you have two solutions, and they are these two right here. Okay, so those are the two real solutions when you have a complex complex roots. So the general solution when you have complex roots is x to the alpha. Okay, it's just like c sub 1 y sub 1 plus c sub 2 y sub 2, right? So if you plug them in, you know that they have x to the alpha in common. So you just factor that out. Okay, you just factor that out. So inside you have c sub 1 cosine of beta ln x plus c sub 2 sine of beta ln x. Okay, so that is y sub c. All right, so we got the y sub c up here. For case 1 is like this. You just do this and plug in the y1 and y2 for both cases, right? But in this case, I just want to do this because this is like it's more complicated. So I want to write it out so you can see it. Okay. Okay. So let's compare that with what you had back in section 4.3. So in section 4.3, you had a regular differential equation, a homogeneous differential equation with complex roots. Your equation would, your general solution would be, because I write just y, I don't write y sub c here, okay? Because this is my original equation, okay? So the solution is e raised to alpha x. So instead of e to the alpha x, for the Cauchy Euler equation is going to be x to the alpha, okay? And then instead of, oh yes, I'm sorry. This is so instead of multiplying the beta by ln x here for Cauchy by ln x. So you just replace the x with ln x, and then you replace the e to the alpha x with x to the alpha. So just those two switch around. So you might need to go over the notes again so you can see how they work. And remember, okay, it is not hard at all, but because there are a lot of stuff written down, so you might not be able to comprehend right away, okay? But let's do the problems. When you do the actual problems, they are easy, okay? So for example, right here, so the first step to do, just like how you did before, first of all, you realize that this is a Cauchy Euler equation. I'm gonna abbreviate. So that is a Cauchy Euler equation because you have the x squared being multiplied to the y double prime, and there's no y prime here. Okay, so we don't have to worry about having an x times y prime because the coefficient of that y prime term is 0. So that is a Cauchy Euler. Okay, so how do you get the auxiliary equation? So from here, the auxiliary equation is, oh, you see my palm touches it, it's zoomed in so big. The zoom. Oh. I have to look for my my glove. Okay, so that gives you 4m minus 1, right? For the y double prime term. And then there's no y prime term, so don't worry about that. And then for the y, you have a plus 1. Okay, so that is the auxiliary equation. And then let's multiply out and find out what m is. So you have 4m squared minus 4m plus 1. So that gives you 2m minus 1 quantity squared. So that gives you m is equal to 1/2. Repeated twice, right? Okay, because it is a Cauchy Euler equation, so you know that y1 is going to be x to the 1/2. Okay, and the root repeats twice, so the second one is going to be x to the 1/2 times ln of x. Okay, so therefore the general solution is y. You don't write y sub c, okay? The only time you write y sub c is when your original differential equation is a non-homogeneous differential equation, because when there's a function on the right, the general solution is y equals y sub c plus y sub p. That's why you want to differentiate the y sub c, the y sub p, so you write y sub c. But in this case, your original equation is a homogeneous differential equation. So you know the general solution is going to be c1 y1 plus c2 y2. So that means it is c sub 1 x to the 1/2 plus c sub 2 x to the 1/2 times ln of x. All right. Okay. And the next one. Now this is again a second order. And you know that the coefficient right here is a 1. So you have 1. So you have 1, right? And then that is the y double prime term. So you have m minus 1. And the next term is the y prime term. So you have 3 times m. Because when you take the derivative of x to the m, you get mx to the m. So that's why you have just m. And then minus 4. All right, and then let's multiply out. When you multiply out, let me skip one step. Okay, because m times -1 is -m, plus 3m is 2m. So that's plus 2m minus 4. And this is not factorable, so you need to use the quadratic formula. Okay, so the quadratic formula is -b plus or minus b squared minus 4ac all over 2a. So that's -2 plus or minus 2 squared minus 4 times a times c, like that. 2 times 1. Okay. So what you have is -2 plus or minus square root of 20 all over 2. And that is square root of 20 is 2 square root of 5. So you can reduce with the bottom, so you get -1 plus or minus square root of 5. Okay. So m1. So this means m1 is equal to, so both are real numbers, okay? So m1 is this, and m2 is -1 minus square root of 5. Okay, so the general solution is y, okay, so I'm gonna write, skip a line, y equals c sub 1 times the first solution, which is x to the power -1 plus square root of 5, plus the second solution, c sub 2 times the second solution, which is x to the -1 minus square root of 5. Okay. All right. Now, the third problem. Do you think this is a Cauchy-Euler equation? Yes or no?
Yes.
Yes.
Yes, right? Okay, it is a Cauchy-Euler equation. However, so let's highlight this. So this is a Cauchy-Euler equation. Okay, so if it is a Cauchy-Euler equation, but remember this is a non-homogeneous differential equation, right? So if you want to solve this one, you have to replace x squared with 0, to get the y sub c. So you do just like what we just did for the two examples up here. But then when you try to find the particular solution, you wouldn't have any idea on how to do it, because so far the only way we knew how to do is when the coefficients of the derivatives and y are constant, right? And now you have variable x here and variable x squared here, so you wouldn't know how. Okay, so that's why problem 33 says make a substitution first, okay, and find out. So you make this substitution. So you let x be e to the t. So let's say for all of the stuff that we have learned so far in this section, let's say I didn't even mention about Cauchy-Euler equation, okay? And I gave you these examples that I just did. You could solve them by making this substitution right here. Then you can turn everything back into equations that you saw in section 4.3, okay? And you will see. So that's why I said, you know, if you see e to the t, you replace it with x. So right up here, from the comparison here. So if you see like c to the x, e to the x, you replace it with x. Like e to the x is like e to the t, right? So e to the t, you replace it with x, okay? And then what is ln x? So ln x is t. So ln x is t. So if you use this one as t, so instead of t, it is ln x. See, instead of t, it is ln x. Instead of e to the t, it is x. So it's all that. So everything is from here, from this substitution right there. All right. So in order for you to use this substitution to plug in here, the first thing you do is you need to find out what dx dt is, because you need to replace x with stuff with t. Okay, so let's write this down. So to do this, so here's what you need to do first. All right, because in your equation you have dy dx and the second derivative of y with respect to x. You need to convert them into with respect to t, because now x is a function of t. So this is what you do. So y prime is dy dx, which is dy dt times dt dx, okay? So let's go over here and find out what this is. Okay, so right here. So I'm gonna separate. Okay, so on the right side, if I want to find out what dx dt is, it's gonna be e to the t, right? So from here, then I know dt dx is the reciprocal, okay? So with that said, then I can say dt dx is e to the negative t, and then multiply by dy dt. That's what I have for y prime. So if I see y prime, I can replace y prime with this. But now what about y double prime? So, and y double prime, okay, and y double prime is the derivative of x. Let me do this. Let me write it out so you can see. It's the second derivative like that, okay, which is the derivative of the first derivative. And this is, and the first derivative is e to the negative t dy dt. But everything here is in terms of y and t, and you still have the dx right here. So we need to use the chain rule to rewrite this. Okay, so this one right here is what? Okay, so that can be written as dt dx times d over dt. See, so you have this. Okay. So that's what you have. Okay. So here you know what dt dx is. Dt dx is e to negative t. And here you have the derivative of a product. Okay, so right here, this is the derivative of u times v. So this is u and this is v. Okay, so that derivative is uv prime plus vu prime. Okay, so let's put everything in here. So you have, and this one right here, and this one right here is e to the negative t. Okay, so what I have is e to the negative t, right? And then the derivative of that product is what? Is u times the derivative of v, which is dy dt, plus v, which is dy dt, times the derivative of u, which is e to the negative t. So that's what I have. Okay. So now let's rewrite. So you have e to the negative t. In here, you have e to the negative t, and that gives you the second derivative with respect to t. And the next one, the derivative of negative e to the t is negative e to the negative t times that. Okay, so what is y double prime? So y double prime is, you factor out e to the negative t, so you have e to the negative 2t times the second derivative of y minus the first derivative of y. Okay. Or you can multiply out. So I don't know, which should we multiply out? Yeah, I think we should. Why do we want to factor out? Let's just multiply out. Okay, so let's do this. Now it is not erasing. Okay, so you should have, let's do this, minus e to the negative 2t. Okay, so that's the first step. So let's write, so that is the first step. So the second step is to make your substitution. So your differential equation is x squared y double prime plus 10x y prime plus 8y equals x squared, right? Okay, now let's make the substitution. So x is e to the t. You square it. Now y double prime is, I'm going to use this. Y double prime is e to the negative 2t. The second derivative with respect to t minus e to the negative 2t. The first derivative with respect to t. Okay, so that's what you have. And then plus 10 times x, which is e to the t. And then times y prime. What is y prime? Y prime is this one. Okay, so you just replace is e to the negative t. E to the negative t dy dt. Okay, and then plus 8y equals x squared. Now x is e to the t, and then square it. All right, so let's simplify everything. So when you multiply, I don't know, let's multiply. So when you multiply these two out, you're gonna get the second derivative. Just that. When you multiply these two out, you have dy dt. And then plus that will give you 10 dy dt. And then plus 8y equals e to the 2t. So now you see, it looks like something that we did before. So I don't need to continue on, right? Okay, so we have done this. So this is the second derivative minus plus 9 dy dt plus 8y equals e to the 2t. Okay, so basically the next step is to find out. So what is the next step? To find out what y sub c is. Right, so find y sub c. Okay, so y sub c is what? It's y double prime plus 9y prime plus 8y equals 0. Okay, so I'll let you. So that gives you m squared plus 9m plus 8. So that should be easy, right? So that is m plus 8, m plus 1. So m is equal to -8 or -1. Okay. So y sub c. So you need to write y sub c because this is a non-homogeneous differential equation. Okay. So y sub c is equal to c sub 1 e to the -8x plus c sub 2 e to the -1x. All right. And then to find out what yp is, then you have two options, right? You can either use the undetermined coefficients superposition approach or annihilator approach. Okay, so the fourth one is to find out y sub p. So for y sub p, we know g of x is e to the 2, not g of x in this case, it is supposed to be g of t. No, we shouldn't write x, okay, because this is a function, an equation with respect to t. So it should be t and t here, all right? Please make that correction, t and t. It should be t and t. It's better to use red so it stands out. T, okay? So g of t. So g of t is e to the 2t. So this is easy, so I'm going to use the superposition approach. So that means my y sub p has to be a coefficient times e to the 2t, okay? So if once you have that, then you know y sub p prime is 2a e to the 2t, and y sub p double prime is equal to 4a e to the 2t. Okay. So the differential equation y double prime plus 9y prime plus 8y equals e. Okay, let me bring it down here. E to the 2t. Okay, so that is your differential equation, right? So now y sub p should satisfy this condition. So now you're gonna write y sub p should satisfy that equation. Okay, so you just make the substitution now. Okay, so y sub p double prime is 4a e to the 2t
And
plus
Professor,
9.
sorry,
Hi.
are we supposed to go on the exam as well?
You can mute yourself, please. Okay, and then plus 8 y sub p, which is 8 e to the 2t. All right, so if you simplify everything, that gives you 4a plus 18a plus 8a. That's 30a e to the 2t.
Yeah, Professor, you said earlier
Yes.
we were going to be able to go over the exam. Sorry, just sorry for the background noise.
Yeah, I don't think I have time to do that. Okay.
Okay.
Yeah. So 30. But thank you for reminding me. Okay. So probably I'm gonna send you the solutions. Okay. So you can take a look at the work that I did, and if you still have questions, you can ask me. But I show all the steps, so when you go over the solutions, you should be able to understand. Okay, so from here, you know y sub p is equal to a, right, which is 1 over 30 e to the 2t. Okay. Okay, so with that said, then the general solution is, well, I've been doing too many examples for you. That's why I'm behind. Okay, it's this. So that gives you y sub c is what? Is c sub 1 e to the negative 8t e to the negative 8t plus c sub 2 e to the negative t plus y sub p is 1 over 30 e to the 2t, but we are not done because the original problem, you see how long if you show all the work, the original equation is x, right? The independent variable is x, so you have to change the t to the x. So right here, x is equal to e to the t. So if x is equal to e to the t, let's go over here. So you know that x is equal to e to the t. X is equal to e to the t implies t is equal to ln x. You see that? So you can just make that substitution. So from here, y is equal to c sub 1. So e to the t is x, right? So you can write like this. So that's e to the t to the negative 8th plus c sub 2 e to the t to the negative 1st plus 1 over 30th e to the t raised to the 2nd power. So y is equal to c sub t, c sub 1 e to the t is x plus e to the t is x, and then plus e to the t is x squared. Okay. We're done for this section. Oh, let me get a sip of water. What time is the class over?
7:50.
10 minutes.
Okay.
So we are running behind. Because my goal is to finish 4.9, and obviously I can't. So we'll see. Let's start whatever we can do today. Let's do that. So let's go to 4.9. Okay. So what is 4.9? Let me go to my, I still have to use my Surface to change the date. Because I cannot, you see, like the date right here, I cannot even make it change on here when I use OneNote app. The only way I can do that is when I use my full version OneNote that I purchased the Microsoft Office. I don't like the Microsoft. What is that? I don't like Office 3. Is it 365? Yeah, I don't like buying that, because then Microsoft makes you pay, right? Like annually. I rather buy the Microsoft Office like one time and that's it. But this section is short, okay? It's short on my end when I lecture, but it may be longer on your end, because when you try to solve, and this is a system, this is solving systems of differential equations, okay? So how does it work? So no concept at all here, okay? It's just like you solve the way that you did in algebra, okay, which is by elimination. So the way to do that is first, you're gonna it's easier if we use the D operator, okay? So for this one right here, if you write this one as D dx, and on the right it is negative y plus t. So in this case, x and y are both functions of t. All right. So when you write the d means the derivative with respect to t. Okay, so that is what your original system gives you. So let's make a note. Okay, so you want to make a note. So where the d operator is actually the derivative with respect to t. Okay, so once you have that, so here's what you do. So when you solve a system by elimination, you look at the system and decide which variable you want to eliminate, just like how you did it in algebra, okay? So here you have the x and the y. So if you want to, in algebra, when you solve by elimination, you move the x and the y terms to the left, right? So, I'm gonna do the same thing here. So I have this plus y equals t, and this is, and I move the x to the left, that's negative x plus, so I line up the terms containing y. Okay. All right. And now you ask yourself, which variable do I want to eliminate? Do you want to eliminate x, or do I want to eliminate y? And it doesn't really matter which one you want to eliminate, just like how you did it in beginning algebra. If you want to eliminate x, then you want to make sure that this term and this term are the same with opposite signs, right? So you can add them up. Remember that? So let's say if you want to eliminate x, then you're gonna operate both sides of this equation by with the d operator, okay? Because when you do that, then what do you get? Then you get dx plus y equals t up here, but down here you have negative dx plus, and then you operate d on dy, that's going to be the second derivative on y. And then on the right side, you operate d on negative t. So let me use bracket. Okay, so that's what you have. Now you add them up. Okay, so now you add them up. So when you add them up, what do you get? Well, you know that these two will cancel out, right? When you add them up, they cancel out. So here what you have is d squared y plus y equals t, and the derivative of negative t is -1, okay? So now it should be easy. So this is a differential equation that you learn how to do in section 4.4 or 4.5, right? This is a non-homogeneous differential equation. So the first step is to find out what y sub c is. So I could have just stopped right here, but let me try to do as much as I can. Okay, so the first step is to find y sub c, right? So to find y sub c, you have d squared y. So this, you know, like if you guys are behind, then you know you're gonna get lost here, because you know if you don't know how to solve, find yc and so on, you're gonna get lost. Yeah. So this is m squared plus 1 equals 0. So m is equal to positive and -1. Okay. So remember, which is like I'm sorry, not positive -1. That's positive -1i. Right. So that is like 0 plus or minus 1i, and that is like alpha plus or minus beta I. So you know y sub c is equal to e to the alpha t, and then parentheses cosine c sub 1 cosine of beta t plus c sub 2 sine of beta t. And in this case, you know, like right here, alpha is 0 and beta is 1, right? So y sub c is what? E to the 0t, which is 1. So you have just c sub 1 cosine t plus c sub 2 sine of t. Okay, so that's the y sub c. So now find y sub p. So what is y sub p? So y sub p, which is d squared y plus y equals t minus 1. So from here, you know the function on the right-hand side is a linear function. So implies the form of y sub p is a linear function, which is a, not ax, because it's t, right, plus b. Okay, so you can do that. So that implies the first derivative of p is a, and the second derivative of p is 0. Okay, so you go back here. So you know that this guy is 0 because the second derivative is 0, right? Or you know what? Let me. Okay, and then y is, what is y? You know what? Let me. So that is y sub p, right? Y sub p. So that gives you 0, and y sub p is at plus b. So you know from here, what is a? A is 1 and b is -1. So y sub p is equal to 1t minus 1, which happens to be the same as the function g of x, or g of t, but not always the case, okay? So let me write this and then I stop. So thus, y is equal to y of t is equal to y sub c plus y sub p. Implies y of t is equal to c1 cosine of t plus C2 sine of t plus y sub p is this. But we're not done yet, okay? So I'm going to stop right here. And then I will continue. I will finish up this example next time before I go to the next section, all right? So I'm gonna put the solution to the test on Canvas sometime from now to Saturday. Okay, I will do that for you. And then if you have any questions after going over the solutions, you can ask me. Okay. So thank you for being patient with me for 2 minutes here, right? The class went over 2 minutes, so I will see you all. I will see you all next week. So, yeah.